Are you recorded? Good morning, Frank. Good morning, Yalin Puga. Good morning, Randy. Good morning, Cesar. Good morning, Queen Prosser. I received your subscription, Queen. Queen Prosser. Do you hear me? Queen, Lauren Guerra, and Sabrina Campos. Okay, guys, don't worry because today we start grade the test because I am busy. I am grading another class. And the process is a little bit complicated because so no, don't think all students are good. The students send me a test I cannot understand. Because I need to communicate again. Please resend me the test in proper way because I don't understand anything. Entonces this is complicated. This is complicated in the first test. Yeah, in the second test, yeah, the student adaptation for the condition, no? Okay. Today is important, extremely important day. Because we are discussing okay, do you see the whiteboard? The zero of the polynomial function. The zero. Good, Andreina. Okay, zero of the polynomial function. Okay, let's wait 1 minute more. Immediately we start. Okay, ready. Everyone pay attention, please. Ready or not yet? Ready? Okay. In the last class, we started discussing polynomial functions. And one important thing inside polynomial function is determine the zeros. The zero is, well, si suppose que this is polynomial function f of x. When you put equal to 0, when you put y equal to 0 and you solve this equation, solve for x, and you obtain the famous 0. Okay, if these 0 are real number, is the famous x-intercept. Another possibility is that the 0 are complex or imaginary, complex number, so belong to the complex field, so we cannot see the representation graphically, because in the graphic you see only the real number, never the complex. The complex is a ghost. The complex when you is because the x in z do not exist. Okay. Entonces, bueno, one possibility. Suppose que the degree m represent degree of the polynomial is degree equal to. Entonces quadratic function. Entonces super easy, and we can use in factorization or we can use in a quadratic formula. If the degree, this is extremely complicated process. If degree is 3, we have formula, but the formula is too big formula is, you write the formula is the size of the one regular piece of paper, the formula. So this formula is completely useless. And degree 4 is the size of the formula is 2 pieces of paper, the regular piece of paper. But this is completely useful, no formula. Yeah, they are formula, but it's completely useless. And degree 5, amazing, and higher 5, no formula. Unbelievable. No formula. To prove this is very, very, very complicated. But I anticipate this idea. But don't worry. One possibility to find the zero of the polynomial is using factorization, no? Okay, we discussed it last time. We discussed it last time 2 examples. Factorization. Factorization is fantastic, pero factorization is weak. Because a lot of examples we cannot factorization. Entonces we study now another way, a little bit more strong to find the zero of the polynomial. Okay, let me recall something. Let me recall long division. Long division. Okay, long division, pero long division of polynomial, ¿no? Entonces, suppose que you divide 2x squared plus 3x minus 14 divided by x minus 2. In this case, always, not always, but frequently, the divisor, okay, degree here is 2, degree 2, and degree here is 1. Normally, the divisor, the degree is 1, so it's only one binomial. So what is the organization long division? Well, the organization long division is, when you represent using that symbol, the classical symbol that we use in arithmetic, you copy inside the box the dividend is the top part. Outside the box, you copy the divisor is the bottom part. And you start. Okay, entonces now you start to say, I think about what is the monomial expression such that when you multiply by the first guy, is this, give me exactly the same of this. Well, it's obvious que es 2x, no? It's obvious que es 2x, because when you multiply 2x times x is 2x squared. And when you multiply 2x times 2 is 4x. You copy exactly here in the same column, no? The column of the x squared, the column of the x, and we have no column here. Well, we have column, but we have nothing here when you multiply. So basically, the thing I did was multiplication, this and this, I copied that. And this and this, I copied that. Okay, now, by subtracting, you change the sign. This is classical in the division, no? When you are doing in elementary school division of the number, suppose you divide 5 divided by 2, is 2, 2 times 2 is 4, and subtracting the remainder is 1. Exactly the same we are doing in the polynomial. In the polynomial, we are doing exactly, by subtracting, you change the sign. In this case, is cancel that part, 0. And this is, wait. This is negative, but by subtracting is positive. Wow. And teaching, carajo. Okay, repetition. 2x times x is 2x squared. 2x times negative 2 is negative 4, but by subtracting, I change the sign, so it's positive. So it's 7. Now bring down negative 14. And we continuation. So we continue because we stop the long division when the degree of this remainder, potential remainder, is less than the degree of this. Degree of this is 1. Degree of this is 1. No. Entonces, the same degree, we cannot stop. We stop when the degree is 1, less than 1, the degree of the divisor. In this case, the degree of the divisor is 1, so you stop when you have degree 0, and degree 0 means a number without x, without variable. Okay, entonces now the monomial in this case is necessary is 7, no? It's 7 because 7 times x is 7x. And 7 times 2 is negative 14. But actually, I change the sign y I get remainder 0. Ajá. Entonces, bueno, okay, fantastic. Remainder 0, that means que this is the answer. The answer of this division is 2x plus 7. I suppose you remember that. Yes or no? Yes or no? We have a yes. Lustin say I remember. Okay. It's fantastic. This is a long division. However, I prefer in this topic synthetic division. Synthetic division. Synthetic division is possible. It's a shortcut to do exactly the same idea, but in short way. And synthetic division is only possible when the divisor, the degree is 1. So let's do it exactly the same problem, but using synthetic division organization. Okay, let's do it exactly the same problem, but using synthetic division organization. Look. Okay, you copy exactly the same symbol. You copy the coefficient C in front, the polynomial in the top, que es 2, 3, and negative 14. 2, 3, and negative 14 without variable, without x. Because I suppose default, I suppose that this is x to the 0 power, x to the 1 power, and x to the 2nd power. Okay? Si one element is missing, you declare it like a 0. But in this case, no. In this case, no missing. Okay, now outside the box, you put this, que is 2. Oh, but very, very important. You put 2, que is the number in the divisor, because I suppose que the degree is 1. So default, you understand que es x minus 2, but you put opposite sign. No negative, positive 2. Why? Because I avoid the idea for the change the sign. I need to change the sign here. Look, 1 time, and you change the sign here 2 times. No. I change the sign only 1 time at the beginning. Instead of negative 2, you put positive 2. And si es positive 2, you put negative 2. Opposite sign in the number of the divisor. And you bring down the first coefficient, que is 2, without do anything. So just bring down. And multiplication, 2 times 2 is 4. And we combine like area, is 7. And 7 times 2 is 14. And for negative 14 and positive 14 is 0. 0 remainder, okay, remainder 0, no problema. And the answer is, this is the answer, right? And so you understand that this is x to the 0 now, and this is x to the 1, and the answer is 2x plus 7. Exactly the same. Fantastic. Synthetic division. Do you remember synthetic division or no? Yeah, you remember. Any question, guys? Okay. So let me try another example. And after I want to illustrate the application of the synthetic division in the solution of the 0 of the polynomial, right? Look, this weird example. This is weird to confuse you. The organization is minus 10 x squared plus 2 x cubed minus 5 division by x minus 4. Wow, what the hell is that? Well, let me try to write in another way. It's confusing, at least for me it's confusing to say. I propose you write in that way, because the way I consider good. That the divisor is x minus 4. And the dividend is this. You organize in descending order of the degree. O sea, this is degree is 2x cubic minus 10x squared minus 5. Okay, this at least for me is more clear. So let me try to do using synthetic division. Synthetic division is, if you copy that, personally, I like this organization. You put x to the 0, x to the 1, x to the second, and x to the third. I know that I stop in x to the third because it's the leading coefficient, the higher exponent. So the polynomial in the top is degree 3, ¿no? Entonces I put here 4. But 4 positive, no? Because it's opposite sign. Remember the idea for the... And the coefficients are 2, negative 10. Ooh, x to the 1, amazing. Now is 0. And this is negative 5. Okay? And this is my problem. Let me start synthetic division. Bring down 2 directly without any operation, without directly 2 multiplication is 8. We combine and negative 2 and 4 is negative 8. This is negative 8 and negative 8 times 4 is 32, negative 32, negative 32, negative 32. And when you combine here, it's negative 37. Okay. I try to illustrate what happened, what the idea when the remainder is not 0. It's negative 37. So what is my final answer? This is equivalent to say, equal to say. This is x to the 0. This is x to the 1. This is x to the second. Entonces the quotient, is the answer for the division is 2x squared minus 2x minus 8. And the remaining part you put like that. For example, you put plus the remainder is minus 37 divided by divided, so okay, is x minus 4. So the formula is quotient. In this example was this guy plus remainder. In this case was negative 37 divided by divisor. In our problem, the divisor was x minus 4. Guys, you can write like that, or you write like that. Either way. Personally, I prefer that way. So this, I discover that this expression is equivalent to this. Okay? Any question? It's clear or no? So basically, when you divide, let me try to explain one theoretical part. Basically, when you have, suppose you have f of x, and you divide by x minus c, you have f of x is a polynomial, degree m. You divide by binomial, degree 1. The answer is a quotient. By the way, the degree, see the degree, this is m. The degree of this is m minus 1. No? You reduce the degree. Plus remainder. Plus remainder. Plus remainder. Remainder r. In other words, you multiply everything by x minus c is equal q of x plus r times x minus c. Entonces, si you evaluate, sorry, carajo. Es. Okay, look. The formula is multiplication x minus c plus r. Like that. Forget about this. Okay. If you evaluate at x equals c, it's obvious that f of x is equal q and c and C, and C, Q and C. This is C minus C plus R. And R is just a number without X. So that part is 0. That part is 0. That means F and C is equal to R. But basically, when you plug any number inside the polynomial, you get the remainder. This is the remainder. However, see the remainder is 0. See the remainder is 0. This is the most important part. That means que C represents a factor or 0 of the polynomial. Okay, let me illustrate the idea. Look, the idea is clear. If F and C is equal to 0, this is equivalent to say that the factor X minus C is a factor of F of X. In other words, guys, what is the procedure? What is the strategy? You perform syntactic division several times. Taka, 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 taka. When you get remainder 0, as you discover that this factor belongs to the polynomial. Let me try to bring one example to illustrate very this idea. Let me try. Suppose, this example. Polynomial f of X is equal to X cubed minus 6X squared plus 11 X minus 6. Entonces I have no idea. I guessing what is the number I plug in here. I guessing. But I want to explain after what is the smart way to guessing. But in this moment, I don't know the theoretical part to guessing. Okay, I want to explain after this example. And you apply several times syntactic division. Okay, let me try to organize in the format of the syntactic division. Okay, it is X to the 0, X to the 1, X to the second, X to the third. Okay, 1 is minus 6 is 11 and negative 6, no? Entonces I make a decision. I don't know why. I want to explain after. Divided by 1. Okay, bring down this 1. 1 times 1 is 1. Negative 6 and 1 is negative 5. Negative 5 times 1 is negative 5. 11 minus 5 is 6. 6 times 1 is 6 positive and remainder 0. Wow, I got it. Therefore, the super fantastic conclusion is that the factor X minus 1 belongs to this polynomial. Yeah, I do the factorization without factorization using syntactic division. Okay, remember one important thing you have to remember. So you divide by 1 positive here. Actually, the thing we are doing is divided by X minus 1. Opposite sign, opposite sign, opposite sign, opposite sign, right? Okay, let me continue syntactic division. So I'm guessing again. Wow. Maybe 2. 1, 2, 3, 4, 5, 6, 7. I don't know. So say 1. I bring down 1. This is 2. This is negative 3. This is negative 6. Wow. Again, remainder 0. Nice. So the factor X minus 2, que es this number, belong also to the polynomial. Entonces, the conclusion is, I continue syntactic division? No. Why no? Because you stop here because I realize that the quotient is degree 1. That means that this factor is X minus 3. In this case, it's the same sign, minus 3. So the factorization of this polynomial using syntactic division I did is X minus 1, X minus 2, and X minus 3. End of story. The question that fly in the air is, Professor, how we select 1, 2, 3? And what order is important? No, the order is not important. The problem is selection. Entonces, to selection this is a little bit complicated, but I want to explain the rule of the theoretical part behind this idea of the selection of the number que you perform scientific division. Si you select right and you get remainder 0, you prove that this is a factor que belongs to the polynomial. Do you understand the basic idea right now? Okay. Entonces, let's move on to the, I want to study 1, 2, 3, 4 theorem que help me to discover what is the number guy guessing to perform scientific division. Okay. The first is a theorem of on the exact number of 0 of a polynomial. Okay, this is my first theorem I want to study. What is the idea? Suppose f of x is a polynomial. Of degree, I want to call always m, degree, equal m. N is a number que en general, suppose que es, you know, it's a whole number, greater than 0. So now, how many 0 we have this polynomial? When we have exactly the same. So our polynomial contains m0. Okay. We have n zeros. But it's important to understand. You counted, for example, multiplicity. Remember, multiplicity is synonym to say repetition. Multiplicity, count. So you need to counted multiplicity and complex. Let me explain in one easy way. Suppose que I spend a lot of time and investigate one polynomial. In the last moment, we have 0, 0, 1, 1, 1, 2, 3 plus and minus 4i. And I investigate using sophisticated computer, I don't know. This is the 0. This is the collection of the 0, the one polynomial. So how many 0 we have? We have 1, 2, 3, 4, 5, 6, 7, and 8. 0. Okay, entonces I suppose que this polynomial, the degree is 8. Entonces you count the real. It's a real, pero multiplicity here is 2. Multiplicity here is 3. Multiplicity here is 1. And this is a complex. And the complex solution normally is coming by a couple, by a pair of conjugate. I want to explain conjugate now. Do you understand the idea for the theorem? So as you face, in the problem we are doing now, you face, for example, one polynomial degree 8, we expect 8, 0. Okay, solution. Incluye repetition, incluye complex. Entonces now, it's supposed that we are doing the graph of this. I suppose that you remember in the last class when the multiplicity is even, the graph somehow touch. Depende, no? Touch in that direction or touch in that direction. When the multiplicity is in that direction, is odd number, cross. Okay. O sea, touch or cross. And this also is 1 is cross. And complex never, because complex living in another dimension. It's not real. Okay, do you understand the first idea for the first theorem or theoretical idea for the zero of the polynomial? The second idea, in my opinion, is super important. Suppose que f of x again is a polynomial. But I've introduced restriction whose coefficients are real numbers. O sea, when I talk about, suppose x cubed plus 3x plus 4x squared plus 5. Okay, the coefficients are 1, 3, 4, and 5. Real number. Maybe positive or negative, it doesn't matter. But a real number. So it belongs to the real number. No, because sometimes we have another possibility. We have another possibility that you have x cubed plus, and one coefficient is 3 plus 4i complex x squared plus 4x plus 5. See, at least there's one complex. This idea is not valid. So we are talking about, que es the majority of the case that we are solving here, coefficient real number. When this situation happens, well, so we have, maybe we have complex solution. Maybe yes, maybe no. Pero si es complex solution, this complex solution is coming by pair of conjugates. Suppose solution number 1 is 2 plus 3i. Solution number 2, mandatory. See, this is solution, 2 minus 3i. They are coming by pair of conjugate. Okay, conjugate. Conjugate in algebra is the same complex number, but the opposite sign in the imaginary part. Now, suppose que some problem, sometime bring me information about one complex number. So given that information, for sure you can imply directly that the conjugate, que is exactly the same complex number with opposite sign in the imaginary part, is also zero of the polynomial. So if f of x is a polynomial and one complex zero is given, you can infer directly that the conjugate is also a complex number. Do you understand the idea? Oh, very confusing. This is a glue. This is the glue. This is the glue. Okay. Another confusing. No, why? You need to understand. Suppose que 2 plus 3i is 0. But when you put together the original and its conjugate, you put together inside, it's like the effect of both cancel out and give me real coefficients. Real coefficiency, okay, no mandatory, but so when this situation happens, real coefficiency, when you get zero, que es complex, another complex is a conjugate. This is the idea. I promise that you see some example today of this. Another third topic. Very, very interesting. This, I like this. It's a theorem of rational zeros. Okay. The word rational, remember, rational means fraction or decimal, right? Irrational is, no fraction. So it's a number that we cannot express like a fraction. It's irrational, crazy. But the number that we can express it using fraction or decimal is called irrational. So there are one theorem can help me to understand the potentially of the rational zero. Suppose this example. Suppose f of x is equal to x to the 4th power plus 5x to the 3rd power minus 2x to the 2nd power minus 11x plus 6, or minus 6. Let me check it out. 2x 4 power, 5x to the cubic power, minus 2x squared, minus, good. By the way, what is the degree of this polynomial? What is the degree of this polynomial, by the way? 4 degrees. Entonces, according to the last theorem number 1, when you finish the analysis of the zero, we can get 4 zeros. Yes or no? I have no idea si es complex o no, pero I have no idea. Entonces, the theorem of the rational is, you know, a little bit useful. A little bit, just a little bit. Not too much. Because say that the potential, and this word is important, potential zero, potential zeros, potential zero of this polynomial is a rational, satisfy this formula, plus or minus p over q. Who is p, who is q? P is the coefficient que contains 0 degree, que in this case is 6. I don't care, well, plus or minus, but you put plus or minus. And the sign is not important. You take 6. P is 6 in our example. And Q is the leading coefficient, que is 2. But you don't divide 6 divided by 2. No. You break it down 6 and 2 using the potential factor. So basically, you 6 instead of 6, you put plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, comma, plus or minus 6. Where come from this? Because on the top you have 6. So 1 times 6 is 6. And 2 times 3 is 6. This is the potential. Bueno, ese divisor of 6, no? 6, si you are doing the factorization, is 2 and 3, no? Entonces, what is the factor que give me 6? Bueno, 6 and 1, and 6 is also 2 and 3. Okay, you copy the factorization of the top, the number in the denominator, no? In the numerator, sorry, numerator, top. And top, in the bottom, que es 2, es, bueno, plus or minus 1, and plus or minus 2. Because 2 is a prime number, is the only possibility is 2 and 1. 2 times 1 is 2. So I create the list of potential zero of the our polynomial using this formula. Look at that. The order is not important. For example, you start in 1. 1, so 1 divided by 1, 2 divided by 1, 3 divided by 1, and 6 divided by 1. So basically it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And now 2. 2 is now 2. 2 divided by 1, by 2, by 3, and by 6 again, no? Entonces, 1 divided by 2 is 1/2. Entonces, plus or minus 1/2. Okay. 2 divided by 2 is 1. 1 I include here. Not necessarily repetition again. 3/2, plus or minus 3/2. Because it's 3 divided by 2. And 6 divided by 2 is 3, que I include here. Okay. And this is my list que forme the potential rational fraction or decimal zero of our polynomial que we try to prove using scientific division. Okay? I know que es a lot of time, it's consuming time. Okay? We are doing now. No, because of course I solving this problem at home. Yeah, I know what's the answer, right? So I go directly to the point. So you try 1. Suppose remember no 0. Oh, doesn't work. You try 2. Remember no 0. Oh, doesn't work. Remember 3. Remember 0. Oh, 3 is good. I don't know. Okay, you need to try. Don't worry, guys. This is a classical question when I teach in that part. There are many ways to investigate this. I want to explain one tool. You have a lot of tools and you select. Okay, let me try. Do you understand where come from this list? P divided by Q. P is this guy. Always. When they have x to the 0 power. And Q is this guy. When you have the higher exponent. Get the degree. P divided by Q, break it down P and different divisor, no? And Q in different divisor. And you form it, the combination, and you get that. Okay, so I start synthetic division. Okay, this is this problem I bring is interesting because you see some interesting thing. I solving using the combination, synthetic division, and also factorization. Okay, let's do it. I copy the format of the synthetic division. The coefficients are 2, 5, negative 2, negative 11, and negative 6. Okay. Do you hear a noise, no? I am living near to the air base, military base. X to the 0 power, X to the 1 power, X to the 2nd power, X to the cubic power, and X to the 4 power. This is the format for the top part. For the top part, no, for the dividend. So I try. This is guessing. Wow, guessing. Let me try negative 1. A negative 1 here. Look. Negative 1. So what is the reason, professor, que you select negative 1? I have no idea. Because I try everything one by one at home. Yeah, I get negative 1. And the rest, I don't know. I bring 2. 2 times negative 1 is negative 2. That's 3. 3 times negative 1 is negative 3. This is negative 5. And negative 5 and negative positive 5. That is negative 6 and negative 6 and negative 1 is positive 6. Wow, remains 0. Good. X plus 1. Remember opposite signs. You select negative 1 here, is the factor is opposite sign. Okay. Entonces, one more, professor. One more. I did at home. Yeah, I realized, que negative 1 again is useful. Negative 1 again is useful. Bring down 2. This is negative 2. This is positive 1. No? This is negative 1. This is negative 6. This is positive 6. 0. Wow. So x minus 1. Repetition again. X plus 1, sorry. Because it's negative 1. Okay, that's a factorization. X plus 1 multiplicity 2. X plus 1 again. So now I want to illustrate now a combination. I can't do that. Continue working with the list. But I highly recommend, when you have degree 2, look, this is x to the 0 power, this is x to the 1 power, and this is x to the 2nd power. Actually, the quotient in that moment is 2x squared plus x minus 6 equal to 0. Wow, and this is super easy doing by maybe factorization or maybe a quadratic formula. Either way, I don't know what is the way that you prefer. In this case, I suppose que factorization is super easy because when you multiply this and this is 12, I don't care the sign. And the combination is 4 and 3 because somehow 4 minus 3 is 1. So we are doing by grouping, no? By factorization by grouping. For example, you copy 2x squared exactly the same, and you replace x for 4x minus 3x minus 6 equal to 0. Now ready to apply factorization by grouping. The GCF and the AK is 2x. We have x plus 2. And factorization by grouping in the second couple is minus 3. X plus 2 equal to 0. Nice. Now x plus 2 I can see que es a common factor. So si you continue doing synthetic division using minus 2, we are doing exactly the same answer, no? Entonces x plus 2 is a common factor, I factor out, and inside we have 2x minus 3. Okay. Entonces, professor, what is the final answer? Bueno, the final answer is then, I discovered que our polinomial f of x contain 1, 2, 3, and 4 factors. We have repetition here. X plus 1 squared. You can write like that. Or either way, x plus 1 times x itself is the same. X plus 2 and 2x minus 3. This is the factorization. In this case, everything was good because, let me see, the zeros of this polynomial are, so you listing the zero, is -1. Okay, so x plus 1 equal to 0. Es -1, ¿no? Coma, x equal, sorry, not necessarily x. I listing minus 2 because x plus 2 and 2x minus 3 equal to 0. Es obvio que es 3 over 2, ¿no? 3 over 2. Okay. Now let me come back to the list of the potential rational. Okay, was -1. Okay, let me using another color. -1 here. -1. -2. Oh, -1. -2 is here. And 3/2 is here. Positive 3/2. No, bro, professor, I am confusing because my polynomial is degree 4. And actually, we have only 1, 2, 3, 0. The problem is the multiplicity. In this case, the multiplicity is 2. Look at that. In this case, the multiplicity is 1. And in this case, the multiplicity is 1. 1 plus 1 plus 2 is 4. Exactly the degree of our original polynomial. Do you understand the idea or no? So in this example, I try to illustrate. Listen to me. Okay, you are smart. In the real life, you apply the combination of the synthetic division and factorization in the way that you prefer. Okay, I highly recommend starting synthetic division, and when you are doing the first stage of the synthetic division, you reduce the degree. The original degree is 4, and you reduce to the 3. In 3, we have no formula. Entonces, you apply synthetic division again. I know that this is a little bit consuming time. This is not the point right now. And until you get degree 2, and degree 2 is super easy, you can use in factorization. I don't know if you like my way to do the factorization. You apply your own way you learn in high school, no? Or we can use in the quadratic formula, ABC, and you get exactly the same answer. Just in case, let me take advantage because I have in Desmos the graph of this polynomial. Case number. No, this is the I have no Desmos. Okay, forget about this. Does you understand? It's okay, but I have a bad news. I using always potential 0. I use always potential 0. Potential 0. That means that the theorem do not guarantee the existence of this 0. Suppose that you spend a lot of time doing this for nothing. Okay, guys? Sorry, but this is the idea for the 0 of the polynomial. It's very, very complicated, very, very hard. Very, very hard. Okay? Let me try to explain another theoretical part. O sea, no necessarily potential means que exists frequently, suppose 80%, pero 20% no. Okay. Another way to analyze the 0 of the polynomial, theoretic, is called Descartes rule. Descartes Descartes rule. Let me try to explain Descartes rule using one example. Because it's a little bit confused. It's easy to understand. However, it's confusing at the beginning. Look, suppose one polynomial, f of x, one example to understand Descartes rule. Suppose x to the fifth power minus 6x to the fourth power plus 12 x to the cubic power minus 12 x to the second power plus 11 x minus 6. Okay, degree 5. We expect 5, 0. I don't know, si complex or I don't know. I have no idea. I'm lost. Okay, but we apply Descartes rule. Descartes rule say you count how many change of signs we have in the polynomial. Entonces I recommend this, this way to indicate the change of sign. This is positive and this is negative. One change of sign. Do you see? Positive, negative. Negative, positive. Another change of sign. Positive, negative. Another change of sign. Negative, positive. Another change of sign. Positive, negative. Another change of sign. How many change of sign we have in total? 5. So I call P, capital P, equal 5. Capital P represent the amount of chain of sign. Okay. And what is important is because the Descartes rule say que P, que 5, maybe we have 5 or 3 or 1. So you subtracting 5 minus something, minus even number, always even. Okay, this is the rule que create Descartes. I try to explain. You subtracting even number. 5 minus 2 is 3. 5 minus 4 is 1. 5 minus 6 is negative 1. No. Negative 1 have no sense. When there's negative, no. So that means that our polynomial have 5 or 3 or 1 positive 0. Positive real 0. This is the combination. And what about the negative? I have no information. Yes, we have information. How? Well, you are doing reflection. You are doing the reflection of the polynomial. When you are doing the reflection of the polynomial, it's obvious that the exponent is even stay the same. However, the exponent is odd, no, change the sign. So our polynomial after the reflection is minus x to the fifth power minus 6 x to the fourth power minus 12 because it's 3. Minus 12 again, x to the second power, minus 11, change. This is change, and this is tail. And you analyze now, let me use another color, green color, the change of sign, but in the reflection. And you see, wow, negative. Everything is negative. Therefore, capital N represents the change of sign of the polynomial after the reflection is 0. That means that we have 0 negative real zeros. So in conclusion, we discovered something. We discovered that we have 5, 3 or 1 positive real 0. Okay. We have no, 0, nothing, negative. And what about complex? We have complex, no, I have no idea. But I try to create one chart like that to illustrate the idea. Look, let me try to do my best. Okay. In the chart, I copy here the positive 0, the negative 0, the complex 0, Series represent complex and total. Y I know at the beginning que our polynomial de degree es 5. Entonces, we expect 5. We expect 5, 0. Entonces, I know que this column is 5. Always. It's always 5. So we have one possibility. 5 positive. No negative, 0 negative. We discovered 0 negative. Y obviously 0 complex. Entonces 0 plus 0 plus 5 is 5. Is the only possibility? No. We have another possibility. We have 3. Remember, we have no real negative, no never, illegal, but you have 5 in total, entonces 2. And remember, the number of the complex is coming by pair of conjugates. So you never have odd number here. You have always even number, or 2 or 4 or 6. Well, 6 is impossible because the degree of 5. And the last possibility is 5 here, again, because the total 0 is 5. We have 1 here, look. We have no negative, and we have 4. Guys, entonces, now this is a clue to start. I don't know si this combination is good, or this combination is good, or this combination is good. I want to investigate now. Okay? I don't have idea what combination is good. Okay, si es 3, si es 1, si es 5. The positive, I know for sure that we have no real negative, and I don't know if we have 0 complex or 2 complex or 4 complex. Okay? Okay. That's it, no? This is just the beginning. The Descartes rule helped me a little bit. When you have practice, you are doing too fast this, and you are ready to start the rational potential 0 and start several scientific division, no? To investigate exactly the 0. Do you follow me or no? Confusing? Very confusing, very confusing. I need to repeat something or no? Come on, guys. Are you there? Repeat. What part repeat? Please help me. What part is confusing? Okay, in blue color, you can see this arc indicate when you have chain of sign, no? The sign here is positive. The sign here is negative. You see, oh, one chain of sign. So you count 5. 5 chain of sign. This P represent the chain of sign in our polynomial. Entonces you always to investigate how many positive real 0 you subtracting even number 2, 4, 6. And okay, 5 minus 5. Well, 5 minus 0 is 5. 5 minus 2 is 3. Y 5 minus 4 is 1. Entonces that means que our polynomial have all 5 positive real 0, or 3 positive real 0, or 1 positive real 0. Similarly, we are doing in the negative. In the negative, you make a reflection of the polynomial. Reflection in this case about the y-axis, no? Suppose that this is the polynomial, you are doing reflection because I want to investigate the negative part. Yeah, I do exactly the same, but I call n, no p. And p is 0. When it's 0, entonces definitely Descartes tell me que we have no negative real 0. No, good. I like that. Yeah, I create one chart, one table to illustrate the possibility, the combination that we have. I need to investigate CSDs, or CSD, or CSD other. I have no idea. Okay, then I come back to the rational potential 0. Que the formula is plus or minus P divided by Q. Go ahead. A ver. Uy. Unbelievable. Okay. Entonces, I go P divided by Q. P divided by Q is plus or minus 6. Remember, I don't care the sign. And Q is 1. Q is 1. Look at that. Entonces es 1. Entonces the combination, so the potential rational zero I need to investigate using synthetic division is the list plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, no? No more combination because 1 here, 1 is nice. So I need to investigate this. Maybe when I finish, I don't find anything. I suppose yes. I suppose yes, because Descartes give me some information. We have 5, 3, or 1 positive. But I don't try the negative. The negative is not good. I know that the negative doesn't work. Only the positive work. This is the clue. Good. Okay, let me try. Synthetic division. Remember, our polynomial is 1, negative 6, 12, negative 12, 11, negative 6, no? Let me check in just in case. 1, negative 6, yeah. 1, negative 6, positive 12, negative 12, positive 11, and negative 6. Entonces I select, I don't know why, positive 1. Okay, let me try to do my best. Synthetic division one more time. Bring down 1. 1 times 1 is 1, is negative 5. Sorry, this is 1 here, not here. It's negative 5. Entonces es negative 5 here. Is 7. 7 times 1 is 7. This is negative 5. And negative 5 times 1 is negative 5. And this is positive 6. And this is 6, 0 minus 0. Wow, fantastic. Now the factor x minus 1 belong to the polynomial. Okay, super. Let me try to. Synthetic division user 2. Bring down 1. This is 2. This is minus 3. Minus 3 times 2 is negative 6. This is 1. 1 times 2 is 2. This is negative 3. And negative 3 times 2 is 6. Wow, amazing. I got it. X minus 2 is also factor of the our polynomial. Remember, the original degree of the polynomial was 5. We are doing 1 synthetic division reduced to degree 4. We are using the second synthetic division. Now we have degree 3. Now I want to use it now 3. Synthetic division using 3. Bring down 1. This is 3. This is 0. And 0 times 3 is 0. 1 and 3. Wow, again. It's x minus 3. It's also factor of the our polynomial. Entonces, stop here because I know que the quotient is degree 2. And degree 2 is super easy. And degree 2 is super easy to solve it because I know very well solution for the quadratic equation. No? So actually, my polynomial is the factorization is x minus 1, x minus 2, x minus 3, and x squared plus 1. Remember, this is missing. So the quotient have no term que contain x to 1. It's something like that. This is the factorization for our polynomial. And what is the list of the potential zero? Potential no, the actual zero is 1, 2, 3, que was exactly the value que I try in the synthetic division. Entonces, en the last part, que es quadratic irreducible expression, when you try to solve it, is x squared equal minus 1, apply square root both sides. Wow, it's imaginary. X is equal plus or minus I. So we have plus and minus sign. In total, we have 1, 2, 3, 4, 5, 0. Que corresponde perfectly with this idea. Look at that. This column say, Descartes rule. 3 positive, 1, 2, 3, and 2 complex. Complex or imaginary, que es the same. Any question? Any question? Of course, you say, Professor, too hard, too complicated, too long, consuming time. No. Why no? Because you have in your hand the famous tool Desmos. So what is my strong recommendation? When you face one problem in the test like that, the first thing you should do is do the graph in Desmos. Okay, I want to do now. This is the example number, let me see in my Desmos. I have no idea. Let me see. Let me see. No, I don't solve this. But let's do it. Why not? Okay, es when we are doing Desmos, in Desmos, immediately you can see, let's open one section in Desmos and one new section. New section. One section in blank. Okay. Let's move on to Desmos quickly. Switching to Desmos. Okay. Okay. Do you see Desmos? Do you see yes or no? Okay, good. Let me try to typing the polynomial, no? The polynomial is y equal x to the 5th power. Let me use on the keyboard for Desmos, que es super fantastic. You put x power 5th power. Okay, there you go. This is the power function, x to the 5th power. Minus 6 x power 4. Okay, move on. Plus 12. Plus 12. Plus 12 x to the 3rd power. Minus 12 x to the 2nd power. Or x to the 2nd power, you can write directly here if you want. Plus 11 x minus 6. Boom. Entonces now, guys, don't frustrate. This is super easy. Because when you are doing the graph, you can see here, clear like water. You click on the curve, you see the x-intercept, que es 3, is 2, and 1, exactly the same we obtain in the scientific division. So my recommendation is, when you need to solve the zero of the polynomial, the first thing you should do is do the graph in Desmos. And after, if you want, verification using the Descartes rule. Okay, you can, of course. Remember, the Descartes rule is an antique idea. When we have no internet, when we have no super fantastic calculator like that, super fantastic graphic calculator like that, like a Desmos or another, because in the market there are several. And at least you have in your hand 1, 2, and 3, and you in the piece of paper you perform synthetic division using 1, 2, and 3, and you reduce the degree from 5 to 2, and to 2 you apply quadratic formula or factorization using quadratic. Clear or confusing? Clear or confusing? Clear or confusing? Come on, I want to hear opinion. You are too quiet. Clear, she says, clear, professor. Good, very good, very good, very good. Very good. Let me try to find another more interesting problem. And let's apply everything that you know. Clear. Let me apply everything that you know. Let me apply, okay, let me try to find one good example. Good example. Let's see. Not good. Okay. All right, let me try. For example. Okay, there you go. This is good. 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 Suppose this example. Suppose we have a polynomial like that. Que is 2x cubed. 2x cubed minus 3x squared minus 11x plus 6. Okay, I need to find the zero of this guy. Well, okay. You put directly in the Desmos, no? And Desmos give me the real zero, positive or negative, because Desmos give me both, no? This is one possibility, but let's wait until the last moment. Suppose that we have no Desmos. We are doing using the idea, no? For example, let's move on to the rational theorem, plus or minus p divided by q, no? In our example, it's plus or minus 6 divided by 2. I did this or not? No, I don't. Entonces, the potential is plus or minus. Sorry, carajo. Now, yes. Okay. You can see now. Let me start at the beginning. Okay, suppose this example, no? And we start like, we are in the jungle. No calculator, no internet, no nothing. And after verification, see everything is okay or not. Or simultaneously, why not? There are no restrictions with this. Let me start for the rational potential zero, okay? It's plus or minus the formula, P divided by Q. In our example, this guy is P, and this guy is Q. So plus or minus 6 over 2, no? Can you break it down like that? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1, and the bottom, plus or minus 2. So the potential list of the zero, I need to verification using synthetic division is 1, 2, 3, and 6. When you suppose can you divide 1 divided by each one in the top. Now when you divide by 2, it's plus or minus 1/2. Look, this and this, no? 1/2. 2 divided by 2 is 1, I half that. 3/2. And 6 divided by 2 is 3, I half. Okay, this is the potential. See if exists the rational is inside this list. Okay? So this is a moment, this is the crucial moment that I recommend go to Desmos. Because in Desmos, I see clear what is that. Because I don't waste the time I try 1, I try 2, I try 3, I try 6, I try 1/2, I try positive or negative, I don't know. So I try in decimal. I go to decimals. Okay, again, share screen to decimals. Okay, I delete this polynomial. I want to put my new one, que es y equal to x cubic. I prefer using the keyboard of decimals. X power 3 minus 3 x squared minus 11 x plus 6. Boom. In that moment, I can see clear like a water. Okay, 3 is good. 0.5, okay, half positive is good. And negative 2 is good. Entonces, dan a clue to start. Do you see that or no? Guys? Entonces, it's okay. Remember, I copy my piece of paper. I copy 3 is 0. Real 0 positive. Half positive, half 0.5 in decimal. Real 0 positive. And negative 2, real negative 0. Degree is 3. Entonces, I suppose que we have, bueno, this is we have no complex, no? We have no complex. In the case, we have no complex because we have 3. Degree 3, 3, 0. Okay, super. Let me try, go back again to the whiteboard. Switch it to whiteboard. Okay, do you see whiteboard, right? Entonces, I set up the format for the synthetic division to negative 3, negative 11, and positive 6, no? Remember, guys, I like this way. I don't know why. X to the 0, X to the 1, X to the 2. This is just organize the column of the synthetic division. I try by 3. Okay, 3, positive 3, I discovered in decimals because I saw in decimals. I saw in decimal 1/2. I saw in decimal negative 2, no? We can use either. I don't know why I use 3 because I need to select 1, no? Okay, so I bring down to, just bring down multiplication is 6. Is positive 3. Multiplication is 9. Is negative 2. Multiplication is negative 6. Remainder 0. Exactly we expect. So the factor x minus 3 belong. Remember opposite side of this is positive 3 here, negative 3 in the factor. Okay. One more. Well, no. Because at that moment, well, okay, let's do it minus 2. Another minus 2. 1/2 no, because it's a fraction. It's more complicated the arithmetic part. I use a negative 2. Bring down 2. Bring down 2. 2 times 2 is negative 4. This is negative 1. And it's a positive 2. Oh, 0 remainder again. X plus 2 belong to this. Entonces now the last quotient is degree 1. This is x0 and this is x1. Actually, so you write this in algebra is 2x minus 1. Look, 2x minus 1. And x to the 0 and x1 and nothing. But the factorization of the our polynomial is x minus 3, x plus 2, and 2x minus 1. Okay. I understand that. However, what is the least of the 0? What is the least of real no, in general, of zeros? Well, S3 positive. Look at that. S negative 2. So when you take x minus 3 equal to 0, x is 3. When you take x plus 2 equal to 0, x is minus 2. And when you take 2x minus 1 equal to 0, 2x is equal to 1 divided by 2, x is equal to 1 half positive. Comma 1 half. Exactly. Bueno, you predict a little bit, and the rational, no? Rational is 3. So actually, the thinking word was S3, S negative 2. Look at that. And positive half. Okay? The Desmos is super fantastic tool can help me to understand the nature of the zero of the polynomial. Let's analyze quickly the two verification, see everything is okay, or maybe fail, or no fail, never fail. The cat is fantastic. Okay, suppose, let me erase that part. Okay, just curiosity. I want to copy the polynomial. The polynomial is 2x cubed minus 3 x squared minus 11 x plus 6. Okay. I want to analyze using the blue color the chain of sign. I can see positive, negative, one chain of sign. Negative, negative, no change. Stay the same. Negative, positive, is change. So basically, P is 2. And what means to be P2? P2 means that we have 2 and 2 minus 2 is 0. 2 or 0, positive real. No, actually we have 2. So what we are doing, and we see in Desmos, look, the 2 positive real is this guy and this guy. 3 and 1 half. We have negative. Well, negative, remember, we are doing reflection. We are doing reflection. When you are doing reflection, the exponent is odd number change. The exponent is even stay the same. This change because it's 1, and this stays the same. And when you analyze the chain of sign, well, this is negative, negative, don't change the sign. One chain of sign, and no, because it's positive, positive. The capital M is 1. So we have 1 or subtracting 2 is negative, does it have no sense. We have 1 negative real. Exactly the same of this. Look, this is the guy gets negative. And we have no complex. So as you are doing, for example, the chart, summarize everything of the nature of the hour 0. This row corresponded with the positive, this row corresponded with the negative, this row corresponded with the complex, and this row is the Torah. The Torah in our polynomial is 3, no? Because the degree of the polynomial is 3. But we have 2 combinations. Why we have 2 combinations? Because we have 2 numbers here, 2 and 0. Only 1 combination. So basically, negative real is 1, always, anytime, 1, 1. However, you have 2 possibilities, 2, 0. And what about, let me analyze complex. So you have 2 plus 1 is 3, and we have 0 complex, no complex. Another possibility is 2, 0 positive, real, 1 negative. So we have here 2 complex, because 2 plus 1 is 3. However, the combination can work perfectly is this. 2 positive real, 1 negative real, no complex. In this example, in total, we have 3. 1, 2, 3, real 0. Any question? What part is confusing? Come on, guys. Putting the chart together. Okay. Okay. Like that is your request, eh? Yes. Okay. Okay, we did that. Just example 6. This is 7, no? This is 7. Okay, 7. Okay, there you go. Okay. One more or no? One more, right? Let's do it everything at the beginning. Okay. What is the step? Step number 1, in my opinion, is analyze the rational potential. Create the list of the rational potential. Entonces, don't waste the time. You go to Desmos, do the graph. In the graph, you can see actually the zero real. The imaginary you don't see, never, in the rectangular coordinate system. Entonces, you have some clue and prove me in the paper using scientific division, using exactly the real zero, positive or negative. And you reduce the degree of the polynomial one by one. After that, well, to verification everything, why no? Let's try to see and descartes the rule and create the chart. This is not mandatory in every case. So in the test, I ask you, because the tests have limited time. No, actually, in the online remote class, we have no limited time, but the test is designed for the regular class, face-to-face. Entonces, this is too long, probably, no? Entonces, I don't ask everything. I ask one specific. Do the analysis of the Descartes rule and create the chart to illustrate the nature of the zero. That's it. Or listing the potential rational zero. That's it. Or verification, see one specific number is zero or no. You perform the scientific division specifically in the number I provide you and see the answer is yes or no. Okay, see you verification when the remainder is zero. Si remainder is not zero, entonces no zero. Okay, let's do one more. Let me try to find one very good to illustrate, because I have a lot of here. Maybe it's not exactly. Let me see. Okay, this is easy. This is easy. Because I have two. Okay, it's no big deal. It's middle complication. Okay, suppose I have polynomial f of x again equal x cubed degree 3 minus 3 x squared minus 10x plus 24. Okay. The goal is find the zero. Find the zero. And after find the zero, this is the bridge connecting with do the graph of the polynomial. Remember, we need more information. We need maybe x in a set, y in a set, and put in decimal directly. Okay. So step 1. Step 1 is analyze the potential zero. And what is the formula? The formula is plus or minus P divided by Q. P is 24 and Q is 1. I like Q1 because Q is 1, so we have no fraction, I suppose. So plus or minus 24 over 1 No, actually we have no fraction because it's 1. When the denominator 1 is invisible. Entonces the potential es plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, and plus or minus 24. Guys, let me check it just in case. I create quickly without thinking anything. But one fantastic way to verification, you multiply the first and the last. 24. 2 and 12. 24. 6 and 8. Sorry. 24. And 4 and 6. Es plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus, the order is not important, no? Let me check in just in case. 24, 24, 24, and 24. This is the potential. Wow, it's a lot of combination. Actually, we have 1, 2, 3, 4, 5, 6, 7, 8 multiplied by 2, 16 combination. Crazy. Crazy, crazy, crazy. Okay, entonces now, what is the next step? Desmos. In Desmos, you can see exactly what of this guy work or doesn't work. Let me try in Desmos. Oh. Okay. Okay, Desmos now. Okay, I put my polynomial. My polynomial is y equals o f of x. You can write either way. X to the cube power. The keyboard of the demo is fantastic for me. Power 3. Minus 3 x squared. Minus 10x. Plus 24. Boom. I get the answer. Therefore, the answer I can see is, look at that. Positive 4, positive 2, and negative 3. This is the real 0. I copy in the piece of paper because I want to verification. This is a confirmation, no? Because you cannot see, no, Professor, I saw in Desmos. No. You need to prove me in the test, no? Because I perform the synthetic division in either order, in 2 and 4, or in 2 and 4, or in 3. The order is not important. Okay, let's do it. I come back, but I have idea. Okay, whiteboard. Okay, whiteboard. Do you see whiteboard? Okay, entonces tu good candidate to be. Tu good candidate to be is 2. Let me start for 2. 2 positive, no? Okay. This is the format for the synthetic division. X to the 0, x to the 1, x to the second, x to the third. The coefficients are 1, minus 3, minus 10, and 24. Yeah, I try 2 here. Bring down 1. Multiplication is 2. Is negative 1. Multiplication is negative 2. Is negative 12. Multiplication is negative 24. 0 remainder is a confirmation, okay, the factor x minus 2 belong. X minus. Remember que es opposite sign of this. Another guy que I suppose que word is positive 4, no? Positive 4. Positive 4 and negative 3. But it doesn't matter what they select. I bring down 1. This is 4. This is 3. This is 12. Wow. 0 again. The factor x minus 4. Do you get the 2 from? Yeah, of course. Yes. Desmos. Okay. In the real life, suppose that we have no desmos. So you need to try one by one. And the potential is 1, 2, 3, 4, 6, 8, 12, 24. And you see, no remain the 0, no remain the 0, no remain the 0, no remain the 0, no. This is not the way that we are doing. We are doing like that. Put in decimal, and decimal you can see the real 0. That's it. Now, you start directly to the point, because I know that if it doesn't work to say I am doing something wrong. Okay? Now, what's the last guy? Well, the last guy is this. The quotient is this. Look at that. And the quotient is degree 1. Entonces, does the order? No. It doesn't matter. I start for 2, 4, but you start for negative 3. The order is not important. This is x to the 0. It's a factor. Why is important? Why not important? Because it's a multiplication. This is x plus 3. Okay, to no. Okay. ¿Cuál es the conclusion? The conclusion is f of x is equal to x minus 2, x minus 4, and x plus 3. Matter, si I change the order, x plus 3, x minus 4, x minus 2, it's different answer or it's the same answer? Matter or doesn't matter? It's the same, because it's product. And in product, so you switch in the order. Well, doesn't matter. Okay, very well. That is the reason que si you start scientific division in different order, well, you get the same answer. Well, okay. What about the list of the 0 of the polynomial? List of 0. List of zeros of f of x. Well, is 2, 4, and negative 3. Exactly, we see. Well, this case was pretty easy, elementary. By curiosity, let me analyze the idea using the Descartes rule to make sure that everything matches perfectly with the thing we know. Remember the Descartes rule, you copy the original polynomial, I analyze in blue color the chain of sign. This is positive, this is negative. One chain of sign. This is negative, this is negative. No. This is negative, 2. P is 2. See, P is 2, remember you subtracting 0 even number. So we have 2 or 0, because 2 minus 2 is 0. Positive, real, zeros. Okay, actually is this and this. 2 and 4. Now make a reflection. When you make a reflection, remember the oldest money change. This change. This no. Stay the same. This change. And this stay the same because we have no x to change. When you use in green color, the same sign, 1, and it stays the same. N is 1. It indicates that we have only 1. Negative. Real. 0. Okay, by the way, it's this guy. Wow, we are the best. Any question? No. Okay, do you consider do one more or no? Or stop here? Because this is a material I prepared for you. One more or no? Yes, one more, Andreina. Okay, let's do one more. But you help me, right, Andreina? You help me to understand. And one more, and that's it, Randy. No more, Randy. Okay. Uh-huh. I recommend everyone open. You can open your laptop. Well, I don't know if you have laptop. You have laptop or smartphone. So you hear the lecture, the lesson of the conference, the video conference in the smartphone or in the laptop. Laptop or smartphone. Laptop. Uh-huh. And the laptop, Randy, you can open Desmos. Yes. Entonces open. Or you are already open. And the other example or no? Uh-huh. Okay, the last example. Let me change the name of the function because always I call it f of x, f of x, f of x. Suppose g of x is a QE, again, degree 3, 7x squared minus 70x plus 400. Uh-huh. What is the first step? The first step is the famous plus or minus p divided by q. But this is crazy because p is 400 and we have a lot of combination. Completely useless. Because it's 1 and 400, 2 and 200, 4 and 100. This is crazy. So sometimes we cannot apply this. No. So let's go directly to Desmos. Let's go directly to help me in Desmos. Okay, let me try in Desmos. Come on, everyone try in Desmos. Are you super familiar or no in Desmos? Super familiar or you don't practice a lot of in Desmos? Sometimes you practice, no? Guy, strong recommend. We use it in this subject, we use in Desmos in one part of the subject, we use it GeoGebra. It's fantastic in another thing. Okay, I try to do my best. I put a y equal x cubed minus 7 x squared minus Andreina. Andreina say A5. Just A and 5, Andreina. A and 5. Okay. Only two real. Minus 70x plus 400. Boom. Andreina say que we have 0 in 5. Good. In 10. In the negative part. In negative 8. Okay, this is a 0. I need to try. In either order, 10, 5, 10, 5, 10 positive, 5 positive, and 8 negative, negative 8. Okay, I come back to the whiteboard. Shut whiteboard. There you go. I am in whiteboard, no? Okay, let me try scientific division. But I have a clue. I have a clue that the good guy are 10, 5, positive both, and negative 8. 1, -7, -70, 400. Wow, big number. Si es big number, I try to start with the big number que está. Because you know, the process of the division, scientific division, reduce the number. Because the division, bring down 1, multiplication is 10, is 3, multiplication is 30, multiplication is -40, multiplication is -400, remains 0. So I prove in the paper que x minus 10 below is a factor que corresponde with the original polynomial. Let me try 5. I don't know why I like first the positive, no? But it doesn't matter, the order, I know. Bring down 1. Multiplication of 5 is 8. And it's 40. Wow, 0. So the factor x minus 5 belong to the problem. And the last factor, x0, x1, is x plus 8. Because the positive is that number. But the factorization is magical, guys. It's factorization without factorization. So we are doing factorization by scientific division. It's x minus 10, x minus 5, and x plus 8. And the list of 0 is 10 positive, 5 positive, and -8. Everything is real, no complex. Okay, nice. Okay, let's do in the last part, que es Descartes rule. In Descartes rule, remember, we take the original polynomial and you analyze the chain of sign. This guy is positive and negative, one chain of sign. Negative stay the same, and this change. So appears 2. So we have 2. 2 or 1. 2 or 0. All right? 2 or 0. 2 or 0. 2 or 0 what? 2 or 0 positive, real. 0. Okay, actually, and my problem is 10 and 5. Now I make a reflection. X cubic minus 7x squared stay the same. Plus 70x change because the point is odd. Plus 400. This is negative. This is positive. And this is positive. N is 1. So 1 negative. 1 negative. Real. 0. Okay, this guy. And obviously we have no complex because we have 3 0 in total because the degree of the our polynomial. Why do you any change the sign? Okay, good. Okay, because good question. Because you know, okay, for example, x to the even number, when you replace x for negative x, sorry, negative x, to the even number, this is like a -1 to the even number, x to the even number. In -1 to the even number is -1, is +1. So -1 to the even number is +1, and +1 is invisible. So unbelievable, it stays the same. And this is logical because it's even function, no? However, when it's odd, different situation happen. When you replace x for negative x to the odd power, is -1 raised to the odd power, x to the odd power, y I know que -1 to the odd power es -1, entonces negative x to the odd power. This is the reason que I apply the shortcut, and when the exponent is odd number, change. and when exponent is even, it stays the same. Clear? Super clear? Super clear? Okay, okay. I understand now. Very well. Okay, guys, stop. Next time we start completely different topic. Okay, I promise that this weekend, pay attention in the blackboard because as soon as possible, I try to grade. I don't start, but today and tomorrow, any situation, I communicate with you. See, I do not receive very well the test, or maybe I make a mistake, no? I am human, no? And you correct me. Any situation, you correct me, professor. So you are, and you're right, I fix the mistake. Okay. Anytime, guys, it's a pleasure to work with you. I enjoy teaching this class. Okay. Goodbye. Take care. Take care. Take care. Take care. Uh-huh.